Hey, so we're actually going to start this unit on page 9. It's called Arithmetic Sequence. And I know it's on page 9. I should have made it at the beginning. Um, but this part of Unit 4 really has nothing to do with the rest of the unit. But it's something that we have to know. So a sequence is just a pattern of numbers. It's a pattern of numbers where the difference between two consecutive numbers is constant. And so, um, for example, if you had like 2, 4, 6, 8, this is a sequence. It's just a bunch of numbers, and there's a pattern to the numbers. And so, if you go from 2 to 4, you would be adding 2. And then going from 4 to 6, you would also be adding 2. 6 to 8, you'd be adding 2. So we would consider 2, 4, 6, 8 an arithmetic sequence because between consecutive numbers, between each number, the difference is the same or constant. So the common difference is the symbol we use is D. And so it's D, and it's basically just the difference between two consecutive numbers. And difference means subtraction, but an arithmetic sequence, they could be going up by addition. So it goes up by addition or down by subtraction. So the way you could tell if it's an arithmetic sequence is it going up by addition or is it going down by subtraction? And so you first have to be able to identify if it is an arithmetic sequence or if it's not an arithmetic sequence. So you have to tell between every single one, like to go from 1 to 5, you would add 4. 5 to 9, you would also add 4. 9 to 13, you would also add 4. So because you're adding 4 every single time, and because the common difference is constant, we would say yes, it's an arithmetic sequence, and the common difference, or D, is equal to 4. But if you go look at question 2, to go from 1 to 3, you add 2. 3 to 5, you add 2. But 5 to 8, you add 3. So because you're not adding the same amount every single time, this is not an arithmetic sequence because the common difference is different or it's not constant. And then it could also be going down, like question 3. Like to get from 8 to 6, you subtract 2. From 6 to 4, you also subtract 2. From 4 to 2, you subtract 2. So yes, it's an arithmetic sequence, and the common difference is -2. So it has to be going up or down by the same number every single time for it to be an arithmetic sequence. And so this time in questions 7, 8, and 9, you're given the arithmetic sequence. We already know it's an arithmetic sequence. So now we need to find the next 3 terms, which all you got to do is figure out the difference and then continue to add or subtract the difference. So for example, to go from 9 to 13, you add 4. So I know that my common difference is 4 for this sequence. That's the pattern. The numbers are going up by 4. So to figure out the next number, all I have to do is take 21 plus 4 is 25. And then 25 plus 4, I just keep repeating that same pattern, is 29. 29 plus 4, 33. And so likewise, question 8, to go from 5 to 2, that would be, you would subtract 3. So the common difference for question 8 is -3 because you're subtracting. So then you just have to do the same thing. To get my next three numbers, I just have to continue the pattern. -4 minus 3, -7, -7 minus 3, -10, -10 minus 3, -13. So you should be able to identify if a sequence is an arithmetic sequence. Is it going up or down by the same amount by addition or subtraction? If it is an arithmetic sequence, can you identify the common difference? And then can you add to the pattern? So then that's the basic part. And then this is the part where they usually ask on like the EOC. For example, if this says find A19. So if it's, say I had to find like, I don't know, the 120th term. So first of all, in question 9, the -8 would be considered the first term in the sequence. The -2 is the second term. The 4 is the third term. The 10 is the fourth term. And so I would have to continue the pattern, right? So this first blank would be the fifth term, the sixth term, the seventh term. So if it wanted to know like the 112th term, it would be a lot of counting. So instead of counting, the pattern every single time until you get to the 105th term or whatever it's asking for, there is a formula that will help you do that. And the formula is this, is AN, the N is a subscript, so it's written below, equals D N minus 1 plus A1. Or sometimes you could see it like this, which means the same thing. A equals A1 plus Dn minus 1. We're allowed to rearrange these. The commutative property says, if you're adding, it doesn't matter the order in which you add. 2 plus 3 is the same thing as 3 plus 2. So it doesn't matter if the D comes first or if it's at the end. And so we already know what D is. D is the common difference. And then A1 is the first term in the sequence. And then we still have to know what N equals. So I'm going to put it over here. N is the term you want to find. So N is equal to the term you want to find. So we know what N is, we know what A1 is, we know what D is, and we know, again, N is the same thing. It's the term you want to find. And so then if you look at question 10, we have to do two things. The first thing says find the nth term, which is basically the generic formula that could find any single term in the sequence. Then we have to find A19. So let's start with the nth term. Before we do anything, always find your common difference. To go from 7 to 13, you add 6. And so therefore, the common difference, D, is equal to 6. And so the very first term in the sequence, A1, is just equal to 7. So those two things that we should be able to find very easily. The first term is just A1, and we're going up by 6, so the common difference is 6. So then, to find the nth term, you keep the n's in the formula. So my nth term would be AN equals, I plug in D, I'm keeping N, and I'm plugging in A1. This is what we call the nth term. And basically, this formula can then be used to find any term in the sequence. So 7 is our first term, 13 is our second term, 19 is our third, 25 is our fourth term. So to find the 19th term, we could continue to add 6 until we get to the 19th term. Or what we could do is, because we want to find A19, that means that N is equal to 19, because that's the term we want to find. So now we just have to replace n with 19. So it's going to be A19 equals 6. Instead of n minus 1, it's going to be 19 minus 1 plus 7. And so, again, I could have kept counting up 6, up 6, up 6, up 6 until I got to the 19th term. Or if I just type this part into my calculator, it's going to tell me what it is. So it's 6 parentheses 19 minus 1 plus 7. Whoops. And that is equal to 115. So the 19th term, A19, is equal to 115. So then, it doesn't ask this, but just so we understand, like, this equation can be used to find any term. So if it said find like A 20, well, just to give you an example again, is we already know that the 119th term is, or excuse me, that the 19th term is 115. So all we would have to do is add 6, and that would give us the 20th term. Or what we could do is just plug in 20 everywhere we see an n. So now if I type this into my calculator, it should give me the 20th term, which is just going to be 6 times 20 minus 1 plus 7, and should just be 121. Because, again, we already knew that the 19th term is 115, so all we have to do is add 6 to get 121. Or, again, you could use the formula. So for the next one, you have 30, 26, 22, and 18. So the very first step is always find what D is. This time it's going down, and it's going down by 4. Because to get from 30 to 26, you subtract 4. So my common difference is negative 4. My very first term is 30. And so I want to find the nth term first. So I keep all my n's. So I plug in D, and I plug in A1. So to find the nth term, you always plug in D and you plug in N1 or A1, and you leave the n's. So it's going to be negative 4, n minus 1 plus 30. That is the nth term, or that is the equation to find any number in the sequence. So I'm going to change it. Instead of 19, let's find like the 27th term. So to find the 27th term, you have negative 4, and I'm plugging in 27 for n, and I'm adding 30. Anytime, again, finding the 27th term, so everywhere I see an n, I need to plug in 27. And then this part is the part I'm actually typing into my calculator. Negative 4, parentheses, 27 minus 1 plus 30. So I do negative 4, parentheses, 27 minus 1 plus 30, which is negative 74. So the 27th term is negative 74, and that kind of makes sense. Here's why. Is because if I keep subtracting 4, right, 18 minus 4, then I keep subtracting 4, I keep subtracting 4, by the time I get to the 27th term, it's going to be negative. And so it makes sense that it's a kind of a big negative number, because you have to continue to subtract 4 like 27 times would be the same thing. So let's do one more. So you got negative 11, negative 8, negative 5, and negative 2. So you have to figure out how you go from negative 11 to negative 8. And so if you can't figure that out, this one's a little bit more tricky, but here's what you do. you could always take your second term, which is negative 8, and subtract your first term. So negative 8 minus negative 11. Take my first term and I subtract my second term. And that's going to give me my answer for what D is every single time. And that's going to be positive 3. So again, it's positive 3 because you could kind of see these numbers are getting closer and closer to 0. And so if I continue to add 3, my numbers are going to go more positive. And then my A1 is negative 11. So this time, again, I'll write the formula up here. It's AN equals DN minus 1 plus A1. So I have to put AN. I'm just finding the nth term. I have to plug in D. And then I have to add A1. So you could put plus negative 11 or you could just put negative 11. Same thing. So that's the nth term. And so now let's find the 19th term, because that's what it asked for. So if we want to find the 19th term, we could continue to add. Like so far we know the first 4 terms. The first term is negative 11. The second term is negative 8. Third term, negative 5. Fourth term, negative 2. So we know the first 4 terms, and we could continue to add 3, add 3, add 3, add 3, add 3, until we get to the 19th term. Or if you plug it into this equation, if we're trying to find the 19th term, everywhere we see an n, you need to plug in 19. And again, plus negative 11 is just the same thing as just saying negative 11. So then I take this part and I plug it into my calculator. So that's going to look like 3 parentheses 19 minus 1 minus 11, which is 43. So the 19th term is 43, which again makes sense because you're going to keep adding 3, so these numbers are going to keep getting bigger and bigger toward the positive number. So it makes sense that we have a big positive number. And that's about it.